Hello everyone, in this lesson, I will talk about IPv4 addressing and its problems. In the same way that your home address and where you live are identified, an IPv4 address identifies where a device is located on the network. Your street address consists of two parts, the street name and the house number, and the combination of these is also unique in your city or county. When you order a pizza, the courier can bring your pizza to your home within 30 minutes. If you give the wrong address, you will not receive your pizza and you do not want that to happen. Similarly, if the IPv4 addresses are misconfigured on the devices, they will not be able to receive the packets that come to them, so you need to have a solid infrastructure on a network. An IPv4 address consists of two parts. The first part is the host part and the second part is the subnet mask section. All devices on the same subnet must share the same subnet partition. If they are not the same, they must be configured correctly as the PC layer 2 frames may be incorrectly addressed. The figure here shows example IP addressing with two PCs and one router. Our subnet here is 10.1.1.0/26. The IP address of the PC here is 10. The IP address of the PC here is also 20. The subnet masks and IP addresses are configured correctly, and the default gateways are correctly configured as an IP address from the subnet where they are located. Here, PC1 makes a DNS query for the IP address of PC2 when it needs to communicate with PC2. The host name of PC2 is translated to 10.1.1.20 IP addresses. After PC1 gets the IP address information from the DNS server, it needs to determine whether it is in the same subnet as PC2. PC1 subnet ID compares the IP address and the subnet mask as binary. This is the binary counterpart of the IP address of PC1, and this is the binary counterpart of the subnet mask of PC1, which compares them to determine the subnet ID, and compares the binary bits of PC1 with the binary bits of PC2. This is how the PC1 subnet ID is compared with the IP address of PC2. Since the binary bits are the same, PC1 concludes that it is on the same subnet as PC2, so it communicates directly with it and does not need to send the data to its default gateway. PC1 creates a frame with its own source MAC address and PC2 MAC address as destination and sends the frame. When PC2 needs to communicate with the web server here, it makes a DNS query to find out the IP address of the web server. After learning the IP address of the web server, it concludes that there is a different subnet, so it needs to send the data to its default gateway to communicate with the web server. PC1 sends the frame with its source MAC address and router 1's MAC address as destination. IP addressing is very important for successful communication to take place correctly. Let's look at what happens if PC1 is configured with the wrong subnet mask. PC1 compares its IP address with the subnet mask as binary. PC1 creates its IP address as binary. PC1 is the binary equivalent of its subnet mask, and PC1 is the binary equivalent of the subnet ID. The binary bits of PC1 are compared with the binary bits of PC2 as here. Since the building bits are not the same, PC1 concludes that PC2 is not in the same subnet and cannot communicate directly with it, so PC1 has to send the data to its default gateway to route the data to the subnet where PC2 is located. But since PCs are actually connected to the same subnet, an IPv4 addressing problem occurs. An incorrectly entered subnet mask causes an incorrect IP address problems, and if the default gateway is not configured correctly on PCs, packets are not forwarded to the correct device. That's all I will tell you in this lesson. See you in our next lesson. Goodbye.